In this demonstration, I'm going to show how oxidation or redox reactions can be used to create usable electricity, in fact, what we call a battery, a dry cell, or a wet cell. So what I have here, we've seen in a previous video that zinc solid will react with copper ion in solution. This is the blue one. And the copper will plate out and become a solid, and the zinc will dissolve and become zinc 2 plus and become part of an aqueous compound, zinc sulfate. The zinc is going to lose 2 electrons, the copper is going to gain 2 electrons. Now again, the electron clouds have to physically touch, and in the previous demonstration we just poured copper sulfate solution into solid zinc and we saw the reaction occur. Well, we can also create a situation where we can make those electrons move through wires, and that's how we can get useful electricity out of a redox reaction. So on the outside here I have a beaker and I'm going to put some copper sulfate solution. You can tell it's copper sulfate because it's blue. And here I have a porous cup. It's like a piece of pottery. Porous meaning is, if you've ever seen a piece of regular pottery, if you water it a whole lot, the water will ooze and you'll see the wetness on the outside. Well, that's a porous, and that's important because this helps us make a complete circuit. So in here I'm just putting some electrolyte solution, zinc sulfate, and I'll put it in here. And then I'll put the copper electrode in the copper solution and the zinc electrode in the zinc solution. And we have some voltage. There we go. Now, why is that porous cup important? Let me pour some zinc solution into a test tube, which is totally non-porous. And let's swap out the porous cup for the glass one. And we get no voltage. How do we explain that? The porous cup is important because electricity has to go in a circle. That's why we call it a circuit. Okay, so what's the circle? The circle is negative charges. Remember, electricity is moving charges. In wires, it's electrons. In solution, it's ions. Okay? So if we look here, 2 electrons are leaving the zinc, going through this wire, going through the galvanometer, showing that we're getting electricity, and then the electrons end up here, and actually we're plating copper out in this copper. We're getting fresh copper here. But how do we complete the circuit? The key is the anion sulfate. The anion sulfate is actually moving from the copper solution into the zinc solution, and that's why the porous cup is important, because that porosity allows that ion to move here, and that completes the circuit. So if we look at negative charges, electrons go through here, from the zinc solution, through here, plates out of the copper, but what finishes the circuit? The sulfate anion, the negative ion, moving into the porous cup. When we used the test tube, it didn't work. Now, let's move to something very similar. We have a fruit-powered clock here. Okay, it says so right there, fruit-powered clock. Is that really true? Let's find out. Well, to set this thing up, let me get a piece of fruit. So part of my lunch today is going to be used for chemistry. All right, what we have here is a couple of metal electrodes. Okay, you want to guess what these electrodes are? Shouldn't be too hard to guess because we just did it. Oh, come on, wires. And if you notice, the clock just came on. The clock just came on. Let's move it here so you can see. It's reading 12 o'clock. It's connected to the apple. Does the apple have the power? No, no, no. They're fibbing a bit. The difference is in the electrodes. We have a copper electrode and a zinc electrode. So we basically have the same wet cell here as here. The apple just provides the electrolytes to allow to complete the circuit. Builders know this too, that you never can let two different metals touch because they will create a potential oxidation reduction reaction. What I have here is what we call a dielectric union. It's a way to connect an iron pipe to a copper pipe. It's old school. Not many places have iron pipes if new construction, but if you live in an older place, you'll have an iron pipe, and new construction usually is copper. So what I have here, to keep the copper from touching the iron, if the copper touched the iron, we get an oxidation reduction reaction, and ultimately the iron would start dissolving and it would leak. Okay? So first there's a little rubber gasket between the copper and the iron. Okay, so the copper piece here. Then we have another plastic sleeve, so we can put this little nut on top and screw it in tight, but if we look at it closely, that red thing is a little plastic sleeve. The iron never touches the copper. So it's always important not to let two different metals touch, or you can potentially get an oxidation reduction reaction.